Top 10 technical considerations when selecting a load balancer. A technical advisory by EdgeNexus. Home of easy-to-use and powerful load balancers. Considerations regarding the platform. How will you be deploying the load balancer? Will you choose to install into a virtualized environment, or will you choose a cloud environment such as Azure, AWS, or Google Cloud? Or would you like to have a hardware-based load balancer? And if hardware, then will you be able to choose which hardware you can use? Consider also, if will you have the flexibility to move your configuration and license to a different target platform without penalty. And finally, remember that when you choose a load balancer, choose it based on the amount of network traffic and not the number of connections. This simple action will save lots of money. Application protocol considerations. An important point to consider is how the load balancer provides for different protocols. Some load balancers offer simple Layer 4 protocols, while others also provide Layer 7 protocol handling. The most powerful load balancers not only have Layer 4 and 7 capability, but also have Layer 7 traffic management technology that can check the traffic data and manipulate traffic content and routing. They also have powerful reverse proxy engines that operate at high speed, thereby delivering very large volumes of data efficiently. Some load balancers also provide direct server return, also known as DSR, and gateway mode, in addition to reverse proxy. One final point. When load balancer vendors recommend using direct server return, it is almost definitely because their reverse proxy technology is not up to par. Security considerations. As a result of increased security concerns, applications both new and legacy are being forced into becoming more secure and more portable across operating system platforms. This has led to a significant move to web-based applications, all of which need to operate under highly secure modes. SSL, or Secure Sockets Layer, is now the de facto method of connection to web applications, as well as Microsoft Exchange and many others. Load balancers worthy of consideration must be able to handle connections that are secured using SSL. You should check that the load balancers you consider must be able to handle SSL pass-through, SSL offload, and SSL bridging, also known as re-encryption. SSL pass-through is the simplest of processes, and is a Layer 4 protocol. As such, it is not possible to perform any security inspections or redirections on the traffic. SSL pass-through also has the benefit of having the least impact on the load balancer's CPU performance. SSL offload is a process where the traffic is decrypted on entry to the load balancer, and then sent onto the target server using standard HTTP. When it is not possible to use SSL offload, due perhaps to the organization's security policies, SSL bridging or re-encryption will need to be used. In such instances, the traffic is decrypted, assessed, and then re-encrypted, before being sent to the real server. The SSL bridging process has the greatest impact on the load balancer's performance, and it is only the very best load balancing engines that are able to handle the loads. In both SSL offload and bridging modes, you can utilize the ability to inspect and manipulate the traffic, should your load balancer have this capability. Load distribution considerations. Load distribution, or more precisely the way in which the load balancer balances the distribution of data to the target servers, is a point worthy of consideration. Most load balancers offer round-robin, and many users use this as they are familiar with this method. However, this method is extremely simplistic and is really not the best method to use. Other load balancers have a method called least connections. This method is fairly efficient, but they detect general target loads by measuring the number of connections open to the target. Advanced ADCs have many other load balancing methods, including fastest, a load balancing method that measures the target response times in real time before sending data to it. You may also find that the very latest load balancers have advanced capabilities to configure custom load balancing methods. When choosing a load balancer, make sure you look and see how extensive and flexible the load balancing methods are, and also how easy they are to select and configure. The importance of persistence. Be aware that a load balancer will load balance every connection it receives on the configured VIP. Even a simple web page will open a minimum of 5 concurrent connections, each of which could feasibly be sent to a different backend target. This can lead to catastrophic results with almost any application. Let us suppose we have an infrastructure where there are 3 web application servers being load balanced. These web servers host an application where the user has to log in, and the login token is stored on the web server the user is currently connected to, and not a shared database. In such a case, you will need the user to connect to the same web server, so they are not forced to log in repeatedly. This is what is called persistence. There are various forms of persistence, with the most simple being IP-based, where requests originating from the same IP are always sent to the same target server until the session is completed. Using IP-based persistence has its drawbacks, especially when super proxies are in place, with many users sharing the same source IP address. To counter this, advanced load balancers have other methods available to use, such as session cookie-based, ASP.NET Cookie, and JSP Cookie to name a few. When choosing your load balancer, please make sure that there is a choice of persistence methods available for use. The importance of health checks in load balancing. How does one know whether a load balanced server is in a healthy state? Having the ability to check the health of a server is critical in load balancing, as it prevents requests from being sent to a server that could potentially be unable to respond properly. There are a number of standard health checks that are available. These include ping, where you test the network connection to the server, but not the health of the application connectivity. Then, there is TCP connect, where the port is checked whether it responds, but this again does not check the application's health and availability. Load balancers also have the HTTP head and full GET methods of health checks. The HTTP head method will make a request to the application and look for a response such as 200 OK, but again, the application could be broken. Whereas the full method will request a page and check the content for a defined answer. For example, the check may look for the words, "Welcome to." Application-specific health checks for RDP, Radius, FTP, and others are also available on some load balancers. Finally, advanced load balancers allow the writing and construction of custom health checks that can literally test for anything. Again, when choosing your load balancer, make sure that you have a range of health checks available to choose from, and the capability to author your own custom ones. Controlling the traffic. Most users may not know that it is possible to fully manage the traffic that enters the load balancer. Traffic management within load balancers is mainly used for handling Layer 7 traffic. Rules can be defined to direct traffic in many ways. You can define actions based on source IP, subnet, hostname, path, browser language, geographical location, and more. You can also determine what to do with that traffic. Some of the many examples are redirecting the traffic, rewriting the headers, rewriting the cookies, changing page content, and more besides. The possibilities are almost endless, and traffic management can form the core of how you protect your information and infrastructure. When choosing your load balancer, make sure that you choose one that has traffic management, with programmable rules, and without requiring any coding, unless you want to use highly paid consultants, of course. Pre-authentication and single sign-on. Did you know that you could protect access to your applications by pre-authenticating users before they reach the server? This can be done using pre-authentication against platforms such as Active Directory, LDAP, Radius, Cisco Duo, and others. Some load balancers also have the ability to use SSO, or single sign-on, so that the user experience is seamless. When choosing the load balancer, make sure that it has pre-authentication and SSO, and the capability to internally authenticate users against Cisco Duo and others. What about protecting your investment with expansion and future-proofing? Most finance and IT heads are concerned about the ability to expand and future-proof the product they have just invested in. So what should you look out for when considering future-proofing? Can the device be updated with major software and version upgrades without the need to purchase a new product, especially when it's a hardware-based product? Can the software be easily rolled back to the last version, or indeed, any previously installed version? Does the product allow for internal expansion to run applications that provide extra functionality? Consider these points carefully when deciding on the product you will purchase. Do you need a web application firewall, or the need to load balance across data centers to ensure application uptime? The use of a WAF, or web application firewall, is being chosen by more organizations as the threat of web and DDoS attacks grows daily. Most vendors provide WAFs in the cloud, or as distinctly separate hardware devices. Check to see if any vendors provide WAF that can be run integrally within the load balancer and externally as a discrete device. This could save considerable sums and expand the availability of your budget. Additionally, ensure that the WAF offered is compliant and uses the OWASP rule set, that it can accept custom written rules, and is also PCI DSS compliant. When it comes to protecting access to your data and ensuring it is constant, you need to invest into a GSLB, a global server load balancer, using its full name. A GSLB allows you to have multiple data center locations and use the GSLB to direct users to the nearest data center. Also, in the event of a data center or server failure, the GSLB will redirect all traffic to the secondary data center automatically. So check out the following 2 points. Firstly, does the GSLB need to rely on an external DNS? It's great if the GSLB has an integrated and authoritative DNS server built in. Second, can it run integrally within the load balancer? Wouldn't it be great if you could do this and negate the need for additional virtual or physical resources, thereby saving you cost? Check these points carefully before making your choice. Thank you for taking the time to listen to this presentation. We hope that the information provided will allow you to make a better informed choice when selecting a load balancer. This video and the information conveyed within is unbiased and has been brought to you by EdgeNexus, the home of easy-to-use, powerful load balancers.